or like your brain is really attuned to those happy paths. And what should we call the non-happy path? I was trying to think of that.
Unhappy path.
The unhappy path, the bad path, the evil path, the sad path. The sad path has a good ring to it.
Best part of hacking when you can just, critical thing, right?
Yeah.
Dude. Alrighty, my dude. This, I think, is one of my favorite episodes of the year. Every year, we just get 10 awesome pieces of research, deep dive it, figure out what has been at the top of the web hacking world in this past year. It's a fun one to record, for sure.
Yeah, I mean, it's the highest total value per time of any episode, I'd say.
Yeah, for sure. But before we got a lot to cover. We got a lot to cover and not a lot of time to do it today. So I'm not sure if we're going to make our deadline that's in like an hour here or not. But before we hop into it, I got to say, man, I have had my head deep in a bug this week. Deep. And to be honest,
actually, so much so that when I message you, my wife is like, "Is Justin okay?" She legitimately asked me to text you and say, "Just ask it." She said, "Ask Justin if he's okay."
Dude, I just, sometimes when you get a vuln, it's like you just go at it. Like, and to be honest, it only normally happens during live hacking events where I go this deep.
Right.
But this is the first time in a while where I've been like, I will exploit this bug.
It probably helped that last week you got multiple 10K bounties from them, right?
Well, that did help. But you go up against a target and you're like, keep hitting wall after wall after wall, but then you just gotta make it happen, and this was one of those times. And finally, after 30 hours of messing with this, it might be a high, it's not even a crit.
Is it because of user interaction? Is that why?
Yeah. Well, the user interaction is required for sure. But it's there's just a monstrous chain and a new CSS. It's a CSS injection, nice. Of course. And of course I had to come up with this new CSS exfiltration technique that I'll eventually post about. But man, it feels good. It feels good to literally what I did, Joseph, was I took my phone, I took all of my notifications. I just said, I'm putting it on do not disturb until I solve this bug.
No way.
And I didn't look at any of the messages.
It went across multiple days?
Yeah, dude, multiple days. This is 3 days. I didn't touch a single notification or a single item on my to-do list. It was painful, but I loved it.
Yes.
And I got it. And I got the bug. So,
That's amazing. I'm going to share it later in the episode, but I'll go ahead and give them a preview right now that I think we work in the best industry by far.
Oh my
gosh, it's for reasons like that, right?
Yeah, dude, it's so easy to just get lost in it. Once I allow myself to do it. And for the past couple months, I used to get lost in it a lot as a full-time hunter, right? But for the past couple months, I've had critical thinking, I've had Kaido stuff, I've had all sorts of stuff sort of pulling at me left and right, mentorship. And man, it felt good to just put everything on do not disturb and just say, screw it, I'm not responding to anything until I complete this bug.
Yeah. Do you think you would have eventually popped it if you hadn't done that?
I don't know, dude. I don't know. We probably hit 4 or 5 different we're done, walls on this bug and pushed through. So I think it required the amount of focus that it got. And to be honest, man, maybe I'm a little optimistic, but I feel like most bugs are that way, where after a while, after you kind of, this is probably just me being hyper confident, but if you put enough time and effort into it, you can kind of bend the application to your will, I don't know. Maybe that's too optimistic. We're struggling with another bug right now. So we'll see how that one pans out.
Maybe that's the case when you have application and interconnected applications that are as complicated as Google does. Then maybe you're right? But there are just some applications that are so simple that it's if there's no gadget, there's no gadget, right?
Yeah, dude, I don't know. We did, and shout out to Integrity, they rock. But when they did the live hacking event in Portugal last year, or maybe it was the year before, one of the pieces of scope that they had was real small, and most people were focusing on other things because of that.
Yeah.
And I was like, nah, I'm gonna focus on this guy, and after staring at it for long enough, I came up with this wonky, client side path reversal chain that had some actual impact. So yeah, they're small applications, minimal scope. It's disappointing sometimes, but there's something there.
Yeah, I feel it.
All right.
Well, we got, like you said, not a lot of time.
Yeah, tight on time. But before we get into it, I do want to hear about this AI blog post you put out and the masterclass you're going to run on it, because I saw it yesterday. I skimmed it, but with all of the research that we needed to read for this episode, I didn't get to read it. So tell me about it.
Sure. Yeah. I'll give everyone the 30-second overview. Basically, I have been asked hundreds of times to tell someone, like, to just answer the question of how do I get started with hacking AI stuff? And I think that there's also this huge gap of like basically bug hunters that want to be able to hack AI, and they're kind of confused about what is AI safety, what is AI security, and then, you know, what security vulnerabilities can exist in certain chat apps, and what kind of interactions exist there. And I wanted to have like one de facto zero to hero style guide. And I think there's going to be, you know, tons more content like this as it goes on, and I'll keep updating it if there are any like new breakthroughs or anything. But I think at least for months and maybe for a year or two, this should be all you need to go from zero to hero.
Dude, sick.
So yeah,
and so it's a living document.
Yeah, I'm definitely going to add to it as we go, especially some of the tools that are coming out. Haddix is dropping some cool stuff in one of his things. But yeah, I'm doing a 3-hour masterclass on March 11th at like 9 a.m. Pacific, 12 noon Eastern. It's only $200. I wanted to make it super accessible. It will be 90% of the content from the blog. So if you can't afford it or don't care, just read the blog. But there are a lot of people who learn better with like a, you know, visual medium. And then also there'll be like live Q&A, and I may talk about a few bugs I found. So.
Sweet, dude. That sounds awesome. Yeah, I definitely need, you know, AI definitely needed something like that where it's just a kind of a playbook to go after those.
I think it'll be really helpful if you're using AI to help understand or attack an application. You can just copy and paste the whole blog in there, and then use that as like the ideation to basically kind of teach the LLM in that moment what you're trying to achieve.
Using AI to teach AI how to attack AI.
Yes. But really though, I mean, I do think like, you know, all of us love copying and pasting in huge context into these large language models right now. And I think it'll be perfect for that. One thing I did want to say was that critical thinkers do have like a 50% off code. So for the teaching there. So maybe you can like pay $35 to save $100.
Yeah, exactly. That's great. That's a good idea. All right. So with that, let's jump right into the content. Portswigger Top 10 of 2024. Each year, Portswigger puts together a panel and takes nominations for the top web research of the past year. And to be honest, it's one of my most anticipated blog posts of the year, I think, because it just pulls together a lot of really good resources. Even the nominations list is like phenomenal. And then, you know, what we do here at Critical Thinking is we take that list and we digest each one of them. And in the past, actually, Joseph, what I did with Joel in the past was then we would then provide our top 10 out of the top 10.
You re-ranked it?
You know,
nice.
Reorder it. We didn't do that this time. I don't know if we'll fit that in at the end. We may like pause and then deliberate or whatever. But the submissions this year were, thank goodness, not as like cumbersome as last year, dude. Like last year, I think there were like 4 or 5 out of the 10 were like 50-page research papers.
Oh my goodness.
So Joel and I like sat down and we had to allocate like 20 hours.
Workday. Yeah.
Yeah. More, dude. Like it took multiple days of prep to kind of get through that whole episode.
Yep.
But dang, I learned so much.
To close the loop, do you know if they commented on if anybody voted for that thing that said, do not vote for this?
Oh, I don't know. I'm sure they just.
I didn't know if they tweeted about it somewhere or something.
Yeah. But to be honest, I was looking at the top 10 this year. We see an odd amount of like write-ups, like you know, vulnerability write-ups, rather than like this is a new technique to attack applications, which, you know, I'm not going to complain about. I love a good write-up just as much as anybody else. But I do think that it would be cool to have a research top 10 and a write-ups top 10. Because there are some amazing write-ups out there that chain together like a bunch of really just commonly known and pretty rare gadgets into a beautiful masterpiece. And then there's stuff like, you know, James Kettle's HTTP request smuggling, which is like, here's a new vuln class, you know? So do you think they're kind of mixed together here?
Do you think that that means we'll have an inordinate amount of research this next year? Because if you think about, if there's a lot of people who just didn't make the cut, right? They didn't get the chance to publish the research or what have you, and they were working on it the last year. It'll probably get published in 2025. So I would expect probably a greater number of like kind of novel pieces of research this year.
Shit, dude. Every other year, we're going to have like a 20-hour prep session for these Portswigger top 10. Maybe so.
Yeah, maybe.
All right. Well, let's dive right into it. We kind of diced them up and divvied them out. So I think I've got one, then you've got two, then I've got two. So I'll go ahead and start with this number 10, and we'll work our way down to number 1. And the number 10 on the list was hijacking OAuth flows via cookie tossing. Thank you for giving me this one, Joseph, because we kind of did the draft little bit. Yeah, and I was hoping I'd get this one because I love to talk about cookies and cookie tossing. And, to be honest, this write-up is like a pretty great primer on cookie tossing and why it's awesome. The author sort of goes through and talks about what is cookie tossing, how do cookies work, what are the cookie attributes. And for anybody who isn't familiar with cookie tossing, the concept behind that is that when you set a cookie, you have the ability to set, well, first, if you're not familiar with it, you're not listening to the pod enough because we've talked about it a lot. But in these attributes, you have the ability to specify a domain and a path for this cookie, okay? The domain is the domain to which the cookie will be sent, and the path is the path to which the cookie will be sent. Well, there's this really awesome combination that you can do where you set the domain not to a subdomain like www.google.com, but to .google.com or whatever, right? And that will send it to every subdomain of google.com. And any subdomain of google.com in this scenario has the ability to set a cookie like that. And they can also set a cookie with a specific path. Now, this Joseph is where the rub happens here. This is where. Well,
I have a quick question. Yeah, when it comes to cookie tossing, do you normally actually have control of some sort of parameter that's then controlling it, or is it like something different? Like, what's the mechanism by which you typically can't control this?
It's typically, semicolon injection. Like you control the value of a cookie, right? So maybe there's some cookie state equals, and then you provide a value via query parameter. And what they're doing is they're taking that value and they're just putting it directly into a cookie, and they're not checking for the semicolon, which is what we've talked about in the past and sort of deemed as partial cookie injection, where you control you can break out of the cookie value context and go into the cookie attribute context, right?
Right. Yep.
And so if you do that, then you gain control of these primitives, domain equals and path equals, that allows you to specify a specific domain and a path. And the reason why that's interesting is because you can make your cookie get priority, meaning be sent first to the web server by specifying a more specific path for your cookie. So let's say there's two state cookies, right?
Yep.
And one of them has no path set, and one of them has path to
/app.
/app or /initiate auth, right? Your more specific path, even if the domain is wider, is going to actually be given priority. And that's sort of the whole concept behind this cookie tossing research. And the author kind of gives a couple scenarios where this is helpful. One is in this sort of CSRF-like situation. So what you can do with this, so let's say you got an XSS on like blah, 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 subdomain.com, right? And you use that to set a cookie and for the domain and specify a very specific path. Now, as the user is going around in the application, let's say that there's like a update address function or something like that, right? And there's no CSRF protections on it, but it's JSON content type, so you can't CSRF it.
Right.
And you set your attacker session cookie for that update address path, right?
Yep.
So when the user goes in there to update their address and their browser sends a request to the server with their user data, their address, our cookie will be attached to that request only for that specific path. So just for that specific path, the user is logged in as the attacker.
Yep. And it will set it as your address so you can view it.
Exactly. So you can exfiltrate data that way. It's sort of like a CSRF, but it doesn't actually happen to the victim's account. It actually happens to your account, but that's bad for the victim, sort of situation. And this is a very, very similar technique to what was discussed with Matan in episode. Geez, I had it somewhere. It was like episode 70.
I wonder if that exists anywhere when you're generating API keys, because that would be the most. That would be like kind of the coolest. Well, maybe it would only generate it. Maybe it would only generate it for the attacker's auth, and so maybe it wouldn't matter. But that feels impactful.
And actually, what happened in the article was sort of something similar, which was linking a GitHub account. And so what they had a callback where you could link a GitHub account, to your flow or to your account in the app. And so when you go through the flow and it comes back and it links your account, that's when the attacker fixated their session to that specific path. So it actually leaked the victim's GitHub account to the attacker's account. And then you could access all their GitHub information.
Right.
So there's lots of cool ways to exploit this. Also, of course, self-XSS, as we talked about in the episode with Matan, which we'll link in the description. But definitely a really cool write-up over here from Sneak. And there's a really awesome YouTube video also that I just tweeted out about it. That's a really good primer to cookie tossing. So if any of you listeners are aspiring to master the cookie tossing technique, then I think that would be my go-to resource to check out.
Yeah, I had a thought a minute ago that I forgot to ask. Is this something that is often detectable in like a deterministic way where you could have like a plugin for Kaido or whatever that actually will just highlight things where the cookie is able? No, because you have to find the vulnerability.
Well, it would be like you need a reflection. Like the partial cookie injection is definitely detectable. You can check the query parameters, and then if it's
and then the set header. Set cookies header.
Set cookies, or but it can also happen on the client side.
Okay.
With document.cookie, right? So it's a little bit tricky to get fully, I think.
Sure. Cool. You want to move on to the next one?
Yeah. Take it away.
Sweet. Yeah. So the next one is ChatGPT account takeover. And I took this one just in the theme of my career path. So I think I ended up taking it second or third in the draft. The listeners will learn what I picked first, since you gave me first pick as we go along. But so this research is from, what is actually the name? How do you pronounce that?
I have no idea, dude.
Harrell Search Security Research, but it's really cool. I actually wonder if it made top 10 just because the word ChatGPT was in the title. It's fantastic research. I'm not saying that, but just, where AI is like so popular, I wonder if people saw that and kind of were more likely to vote for it. But it's really neat. I think, honestly, I relearn cache deception twice a year. I don't really use it much. And then when I read about it, it's like, oh yeah, this is how it works. It definitely feels like something that could be detected or at least highlighted by specific tools to find them. I'm sure lots of people have written those, but it'd be great if someone would write one of those for Kaido. And so, cache deception, for anyone not up to speed or in case we have some new listeners, is basically where you're caches are very, very useful for loading static content such as JavaScript files or images or whatever, stuff that's not going to change. And it's totally safe to do so. But anytime you are able to cache someone's data, like someone else's data, or I guess you're always mostly going to be caching your own data at an endpoint, then someone else can browse there. An attacker can browse there, or they can kind of force you to click a link, or it's kind of like RxSS where you click a link, it caches your data, then the attacker browses to that same link and your data shows up because it's cached. And so this vulnerability exists anytime a company is caching a path or a route or an endpoint that hosts sensitive data when they shouldn't be. And so you can detect that with the header. It's for Cloudflare specifically, it's cf-cache-status, but it's always called hit is usually the header, HIT.
Yeah, hit or miss is typically what you see. Yeah.
Yeah, and then you can see dynamic as well, right?
Yeah.
Do you look for these much? That was one thing I was going to ask you, was whether you look for cache deception much.
Yeah, I haven't looked at it as much. I mean, I've definitely reported, probably 10 of these
nice.
On HackerOne in the past, but I think it was something that I was focused on a little bit more back in 2023. And I haven't reported them quite as much over the past couple of years. So it's something that I need to pay attention to. And I do think that since it is something that's happening over HTTP, it is particularly well suited, without a lot of client side interaction. I think it is particularly well suited for like a Kaido plugin or something like that to sort of detect what could be going on there. And there's definitely an amazing set of research that came out at DEF CON this past year that we covered in the DEF CON episode from the Portswigger research team on like crazy ways to get stuff cached. So that definitely goes in conjunction with this really well, and would be a good place for anybody who wants to sort of get up to date on this vuln type.
Does this happen? So I was going to ask you this as well. I didn't know if in any of that research they mentioned, does this happen as like a Cloudflare misconfig, or does this actually happen on the server where they've written a piece of code that determines where it gets cached or determines what gets cached?
it's a little bit of both sometimes, depending on the configuration, but a lot of times it's the problem of the caching proxy. So whatever's causing the cache, you've got it misconfigured in such a way that it will cache, based off of URL extension
path with a wildcard or something. Yeah,
exactly. And so if one of the most common ones you'll see is like ASPX has this really liberal path delineations. Like it just if you hit whatever.aspx/abc.css, then it always just is like, okay, that's just the ASPX file, know. And then but it looks like that file ends in .css. So the caching server is like, all right, I'll cache that.
Yeah.
And so, and I think one of the other things they mentioned in this article was that this is actually really commonly done with path traversals as well. So excuse me, my throat just gave out on me. So the author here uses %2f ... %2f in this write-up, to make it look like the path is actually under /share, which should be a cacheable endpoint, but then proceeds to do the path traversal because the server is processing %2f as a directory delineator, a directory delimiter. And that's what sort of was able to cause the vulnerability to occur. Yeah,
if someone wrote this tool, like a tool specifically for this, I would say they should like always check for /JS %2f ... %2f because JavaScript files are going to frequently be cached. Similar, if there's like a /assets/images, do it there as well. And so you can kind of check for all of those separate things. Yeah. So what they did was for this, they were able to cache, like Justin just said, it was caching shared content. So in ChatGPT, at least at that time, you were able to share a thread or an AI response, and the links were always like /share/chat-UUID. And so they were caching everything there. And I was actually going to ask you, is this considered client-side path traversal or just a standard one? It's kind of weird.
It's like it's more like a secondary context thing, right? Where like there is a server somewhere along the line that's not the cache server that is processing that %2f as a directory delimiter, and that's why they're able to cause this whole thing.
That's fair. Because the caching server is not normalizing the path, but then the backend server is normalizing it.
Exactly. And one of the things that I think would be really cool from a research perspective, or somebody that wants to make a plugin or something like that, is to figure out a way to inform hackers in a meaningful way what the different application segments are and what kind of headers are being responded with in this area, right? Because the reason why this worked in this scenario is because there's caching configured for the /share section of chat.openai.com. And so if there's a good way for us to sort of understanding like, oh, okay, over here doesn't have coop headers, over here doesn't have extreme options headers, over here seems to be caching stuff. That sort of information is really valuable to us, and I think is not really formalized in a way that's very readable at this point.
Yeah. Do you think that maybe some sort of visualization based plugin or software where like, as you're hacking on a website, it's like kind of learning, like you said, the different context and drawing it in just like a very simple, like, TL draw style thing where it's like this and this. Yeah. That'd be good.
That could be cool. And to be honest, maybe it would be even easier to do. You could just say like cache segments, extreme options, no extreme option segments, and then provide the like highest level path that does not have that header, present in the response. And it's a little bit tricky because like sometimes 404s have different headers and, but it is interesting for sure.
Yeah, well, maybe it would only do it for requests that actually exist in the sitemap. So then you don't have to worry about 404s and 500s and that sort of thing. Because if you brute forced it or checked it, then of course you would deal with those issues. But if you were just looking at what actually exists in the natural browsing history, it would be much more likely to be real. So that little piece of path traversal actually made it what's called a wildcard cache deception because you could basically go to any path to cache it. And then they reported it, and this was shortly after OpenAI started their bug bounty program, and they paid $6,500 for it.
All right, cool. So what's this one next? We got OAuth non-happy path to ATO.
I'm actually really glad they put happy path in the title because that was one of the coolest things that I took from this. Rereading this, I'm like, man, I just love the idea of a happy path. I think it's something that we all mentally do who've been in like the hacking game for a little while. It's like you have to understand how that application works normally, so then you can understand when things are kind of weird. And that understanding normally is actually a really key piece. And I think it's probably a reason why spending a lot of time on a single program can often pay off, because now you know all of those happy paths. And, you don't always know what the no's are in an application, as Douglas Day always mentions. And I think by understanding the happy path, you can see all those no's pop out because your eyes are, or like your brain is really attuned to those happy paths. And what should we call the non-happy path? I was trying to think of that.
The unhappy path.
The unhappy path. The bad path, the evil path, the sad path. The sad path has a good ring to it.
It does.
So the sad path makes the developers sad because they have to pay us a bounty. So, so when I was reading this one, it's called OAuth Non-Happy Path to ATO by OXRZ. And so he was working on a public bug bounty program. It looks like the happy path, he calls it non-happy paths. The happy path and sad path actually somehow, or the happy path comes from Wikipedia, and he got the non-happy path from our boy Franz Rosen's write-up. So
love it.
Probably Dirty Dancing. Yeah, it is Dirty Dancing. So the cool thing here that there are a couple key cool takeaways. We have had an entire episode on OAuth, so I'm not going to break all that down again, but I wanted to mention a couple of these quotes. So one is, I tried changing the response type parameter from code to ID token. I don't know if we covered that on that OAuth episode, but I thought that was a really cool technique. And then they mentioned later, because there's like 3 different forms of OAuth that this app supported, that is not possible with GitHub, with logging with GitHub. And it's not possible. Facebook has this kind of interesting thing where you have to like click to continue as the user, which changes the referrer header. So that ended up not being exploitable either. And then kind of the combination of using the ID and the token thing here is that Google allows you to pass multiple response types. So you can do ID, token, or code, or comma separate them.
Right.
They both work. Yeah. And then, this actually, it feels like it might be, HX01 is a decent friend of ours. He hasn't made that much noise lately, but he's still doing bug hunting. I was talking to him recently. He's found a lot of issues in OAuth with Google, logged in with Google implementations. And I wonder if this is why, because kind of some of the stuff they support from a complexity perspective. So with response type ID token, or comma, or code, you still end up at a page where you, as that we're all familiar with, where you select which account to log into, which then breaks the referrer part of his payload. But then this part was something that I thought would be really highly valuable to all of our listeners. If you use prompt equals none as a parameter, then the users who are previously logged into Google, it bypasses that page, and I think just logs you in with your primary.
Absolutely.
Which I never knew you could even do that.
Yeah, that's a super useful gadget. I've used that many times.
Oh, okay. Well, maybe it's much more common for the OAuth hackers.
I mean, you see it at live hacking events, or like I've kind of done a couple deep dives on OAuth before, but it is super helpful. And I think the changing the response type also, like, because if I remember correctly, it ends up in a fragment still. Right, it doesn't end up in a like a query parameter. With when you provide multiple of those values there, at least it possibly can.
That's
which is super helpful for being like, okay, well, I still need the code because that's how I redeem it on the application, but I want it in a different format so it's not consumed as soon as it comes to the page, and thus it's in the fragment. Why
would they ever support comma separated response type?
I have no idea.
Okay, because like when I was reading this, I'm like, why? That feels like just something Google should fix, because it seems like even using the analogy of happy paths, really powerful way to explain this. Basically, even if there are multiple happy paths, you would never want a user to be able to go down 2 paths at once. It doesn't make any sense for logging in. It's like you're logging in one way or you're authenticating a different way. You can't do both at once. And Google's like, nah, you can do both at once.
Yeah. I'm not really sure what use there is for that, because typically you're swapping the code anyway for a token on the server side. So not sure what's going on there, but it is definitely a helpful gadget and can help you map out those unhappy paths or sad paths or whatever we're calling them for OAuth flows, which is very helpful for getting ATO.
Yep. Sweet. that is all I had. If you want to roll us into number 7.
Sweet, dude. Okay, we're dude. All right, we're doing it.
We're doing pretty well.
We're making pretty good time. This, I think I kind of was like, all right, got to be ready, Joseph. It's going to be a big episode. Get ready, because last year was so intense. But I think this year, with a lot of write-ups, it's mostly just sort of covering the main takeaways from the vulnerabilities, and then kind of moving into the next one. So.
And on top of that, I think it helps that we've covered so many of these. I don't know, maybe that was something you all did last year, but maybe it was less so.
Yeah, dude, we've covered like at least 7 out of 10 of these before.
Yeah, over half for sure.
Yeah. So speaking of that, we covered this number 7, which is arbitrary JavaScript execution in PDF.js. We covered that in episode 72. So if you want to go back and kind of get a little bit more of a deep dive on that, you can. But the TLDR of this write-up is that the author is providing a PDF to a library called PDF.js, which I believe is the default library used in Firefox to render PDFs if you just open it up in your browser. And I think this is a really cool technique, a really cool way to kind of go a layer deeper by working with a file type that isn't like typically considered to be web stuff. You got like HTML, SVG, XML or whatever, and all of these web types. But PDF is something you kind of think of more as a file. And he kind of goes in there and analyzes how this JS library is parsing that out at a lower level, which I think is very applicable takeaway for anybody who wants to do research. And what he kind of stumbles upon is that this PDF.js, sometimes it relies on the browser to render specific fonts, but other times the PDF.js is responsible itself to render these glyphs. And let me explain what a glyph is really quick. A glyph is a path that should be drawn to represent a character, right? So, if you're doing an I, the path will have like a little dot at the top, and then it'll have a space, and then a line if it's a lowercase I. And that is represented by, however the specific font represents that. And PDF.js is responsible for rendering those glyphs in some scenarios. And so what it did to do that was it would create a JavaScript function which would render that specific glyph. And when it did that, it passed a piece of the PDF that you supplied into the new function call, right? New space function, and then you kind of call it, which is the function object constructor, which is essentially eval if that function gets called.
Right.
And so this is, I think, is an underrated sync new function, and who knows whether it's being used very, very often. But the parameter you pass into that is just raw JavaScript code, and then it gets kind of. Could we do a
GitHub search to find out if it's used like in like open source stuff?
Yeah, I'm sure it'd be all over the place, and it's just one of those ones that's just not very high profile, So that was one takeaway for me, and the other takeaway was sort of got from this quote. It said, if we instrument the PDF.js code to log these generated function objects, then we can see so on and so forth, right? So it's clear here that they have set up an environment where they are debugging this, which is not very hard to do in the browser when you're dealing with JS libraries, right? You've got dev tools all set up. You don't have to worry about hooking into like a debugger or anything like that. The JS engine is already, debugged by dev tools. And it's just cool that they are, making sure that those breakpoints are set and kind of jumping into this. And when you go back and you look at it, it's like, wow, this is so simple, but it definitely took that extra mile of like, let me identify this non-traditional sync and sort of trace through all of this PDF.js code to see where the sync is used.
Yeah, 2 quick things. One, speaking of dev tools, you just did a masterclass for critical thinkers. So if anybody hasn't watched that, they can go watch it or sign up and go watch it if they're not currently one. But on the second thing, I was curious. So does this execute in the context of the web page? So if they're rendering it, is it going to actually execute with full control of the cookies of the page that's loading it?
Yeah, it is. And when you open up a local PDF as well, this is in Firefox, then it will execute with the file handler.
Yeah, I saw that. What access does the file handler have?
It's got a lot of stuff. I think there were some things that were a little bit different here. Let me see if I can jump in here. Interestingly enough, this is not a file path you see in the URL bar if you download the file. Instead, PDF.js runs under the origin resource PDF.js. Okay, so it's a resource file. This presents access to local files, but is slightly more privileged in other aspects. For example, it is possible to invoke a file download, even to download arbitrary file URLs. So it's a pretty privileged context that this executed inside of Firefox. So very cool.
That's kind of neat, because I feel like when I read this, and especially as we were talking about it, I'm thinking like, oh, if there's a website that has a PDF.js that's rendering the PDF, like that's where the vulnerability is. But this is interesting, because if you have file upload on a company's website or whatever, and generally, and if the application itself is like commonly using PDFs, you know, like let's say you're a shipper and you're uploading shipping labels or something, right? If you uploaded a malicious one where employees would download and then open, especially right there in Firefox that they're already using, this would have some pretty big impact. I wonder, did they say, it's a CVE, so it was fixed.
It's all fixed, unfortunately. But you know, if in Firefox, if they're using an older version of Firefox, it definitely could be impactful.
Sure. Or if you find something similar in a different library or what have you. So
the other thing here is like when you're looking at this write-up, the way that they outline the code is really clear, and I'm sure it was like obfuscated and had a bunch of like other stuff surrounding it. But the way that they output this code block is like, wow, yeah, that seems like a vulnerability. But one of the things that would have caught me up a little bit is like they pass an integer into this function, right? A function constructor, and that gets passed as an integer into the resulting function. And they needed it to be a string for it to go into the JavaScript like that and be rendered as a variable. And
why don't you share your screen? Just
sure.
I know that production loves us to do that a little bit more, and that font matrix code block there is like pretty neat.
Oh yeah, for sure. Let me do that. Okay. So down here at the bottom, right here, you can see this is the output of the function right here, this c.transform, and there's integers being passed into this, which originate from this font matrix thing. But originally it looked like, let's see if I can find the one. Originally it looked like this, right? So these were all integers being passed in. And for them to, one of the things that would have caught me up a little bit is that inside of the PDF, I'm like, how do I even render a string? And apparently in PDF, strings are rendered with parentheses, not double quotes. So this parentheses foo bar here that ends up getting put inside the function body is the representation of a string inside of PDF language. Right. And so I just like how they sort of went deep in on this whole PDF structure and understood all the various primitives and types that they have, and then utilized that and the difference between that and the JavaScript code here to get a really crazy bug that was really reminiscent of a bunch of like Flash related vulnerabilities and stuff like that.
Yeah, that's interesting. I'm sure they've probably looked into it, but I'd be curious if this exists and like other functions in here.
Yeah, for sure. This one, number 6, is called DoubleClickjacking, a new era of UI redressing. And dude, like we've covered this on the podcast before. I kind of love this research, but it's kind of like a little meh. I don't know. So first, let me just start by saying, if you click on the link to go to this website, which we'll link in the description, at the very top of that page, and I'll share my screen now. At the very top of that page, there's this little bar right here, right? Where you can press play and hear a podcast generated by Notebook LM explaining this whole flow. And dude, we're cooked. We're cooked, man. It's a good podcast. Like I was sitting there reading through it and listening to it, and I'm like, oh my gosh, this thing is so good.
Yeah, I do a little bit of AI consulting for businesses to help them know how to implement AI. And that's like the biggest thing that blows their mind. So I'm just like going through it. And then I say, oh, and by the way, I generated this podcast about your company and what you sell and what you do. And they start listening to it and they're like, wait, what? It's like, I really wish that Google would release how they do such great like speech or text to speech where it sounds so natural. The podcast hosts sound like completely real.
Yeah, they hand off back and forth. It's like, it's pretty crazy. So
yeah, we're definitely cooked.
Yeah, exactly. So anyway, that was a little scary. But after I moved past that and came out of the fetal position,
you didn't double click the play button, right?
I did. I would never double click anything.
Okay,
I would never double click anything ever again.
Good.
Because what this research is talking about, you see that transition? That was a good transition there. Is how you can harvest double clicks essentially to perform CSRFs within an application. So we covered this on the pod a little bit before, so I'm not going to spend too long on it. But as a refresher for you guys, the flow of the attack sort of goes like this. And this, by the way, is sort of what I'm talking about when I say security research, right? Like this, I think, is more security researchy than some of these write-ups that are here, even though the write-ups are like mind-bogglingly good because this is a new attack, right?
Yep.
And so anyway, how this works is you get two windows open. So that requires one click anyway, right? You click to open a button. And now you're in the second tab. And as the second tab, you have the reference to opener, and you can redirect opener to a page that will have negative impact on the user if one button is clicked on that page. The traditional example for this one that he uses in the blog post is like an authorization endpoint where you're saying like, yeah, I'll install this app on my Shopify store, or like, yeah, I authorize, this user to have all my data. And it's just accept. And then you do that and it's done. Right. And so then what the attacker does is, they pop up a CAPTCHA or whatever and say, hey, double click here to incur, to bypass the CAPTCHA. And so on the mouse down event, which is the first thing that happens when you're clicking, it closes the window. And then you've got sort of like a beat of the mouse up. Right. And then when you press down again for the second aspect of the double click, now you're focused on the window that was the opener of the window that you were intending to click on, which has now been redirected to that app.
Does it actually happen that fast in a lot of apps? Like the first window receiving the command from the second window reloads on this new authorization page fast enough that the second click happens quick?
It's not a reload thing, because that's why you need two tabs open. So as soon as you're in that second tab, you redirect the first tab to.
Got it. So it's waiting.
It's just sitting there waiting, fully loaded, ready to go. Right. So then on the attacker's tab, you put the button they need to double click. You put it right at the correct index.
Oh, of course.
That like as soon as you close the page, their mouse is sort of hovering right over the approve, or accept button. And then
it's just really funny thinking that like slow computers where Chrome is most of the RAM, when they click the button to close the first tab, it takes the computer like 3 seconds for the tab to close. So the second thing still happens on the first tab and nothing,
I'm running like 128 gigabyte server that I'm talking on right now, and it still does that sometimes. I don't know.
When you close the tab, it just hangs for a second.
Yeah, it's nuts. But it's a cool technique, and
it's really cool.
Yeah, and I think as far as takeaways from this go, because we're trying to give technical takeaways for each of these. The technical takeaway is that whenever there's like one single point of failure, one click is a single point of failure in an application, this is a technique that could be used. And
so is the first gadget something like client side, like post message that is like what enables the attacker to load that second page with the reference back to the first?
It's just window.open. So like you on an attacker controlled page, like you do you get a click, and that does a window.open. So now you've got two attacker controlled pages open, right? And then you redirect the first one to the victim site.
Which you could do, yeah.
Yeah, which you can do because it's
all they have to do is be logged into the app that you're trying to attack.
There's no other gadget that you need besides like one click to take over an account, right?
Wow.
So it's pretty impactful. And what he says is most have chosen to address it while some have not. That's a quote from the article, is saying like these companies have typically accepted this report and addressed it in one way or the other. Now, what he didn't say is Is there wallet connects?
Is there wallet connect for one push? For one clicks? But you're laughing. No, I'm being dead serious. That's where the most impact is.
Spinning right now.
No. One, you're right. I didn't realize that DoubleClickjacking required basically nothing other than the fact that there's like a state change or an important thing that requires you to click through. But that's really common these days because your browser already has like a session for Google and a session for GitHub and a session for Discord because you're like long lived across all of them.
Exactly.
So there are so many things that are one click to connect.
Yeah.
So it's kind of surprising to me.
Yeah, 100%. I mean, to be honest, like typically something that requires one click and then a double click, I would be like, that's a little bit, I don't know, like as far as user interaction required goes. But I mean, the impact is there, like, and it's who isn't going to do it? Who doesn't double click on a CAPTCHA, if it says double click here?
Right. It looks like, especially if it looks like the Cloudflare one, the one that pops up where it just requires one click.
Yeah.
If they change it to double click, it would not surprise me in the least.
Oh, 100%. So anyway, the other thing I really liked about this one was he did provide a pretty reasonable method to prevent this from happening, which is on your single point of failure pages, right? You should disable all buttons unless a mouse move event has occurred, because there's no mouse move event when you're double clicking, right? You just are on that page and you're clicking. There's no movement. So it's a pretty actionable thing to put on a page that's pretty high impact from a security perspective to your organization. So I could definitely see some companies addressing this and actually paying out a bounty for it.
Yeah. Honestly, that would probably help with some of the AI automation based stuff too. Just like detect real users. So.
All right. So the next one,
you got 3 in a row, by the way. So
yeah. So we're sort of, but we're actually going to skip this one. The number 5 is exploring the DOMPurify library by Kevin Mizu, and we literally just did a whole episode on this, like 2 weeks ago.
With Kevin.
Yeah, with Kevin.
It's not like you and I covered it.
No.
You had the author.
2-hour-long episode with the man himself. So go listen to episode 111 if you want to get to it. And I will say it's a little bit of a cop-out because on that episode, we technically covered the second article, and this is the first article. But I think the second article is more applicable for bug hunters anyway. And this is another scenario where it's like, here's a write-up of a bunch of vulnerabilities in DOMPurify, which is great and is definitely, an amazing write-up. But it's not like, here are a bunch of techniques that you can use to attack an application that are, a new vulnerability class or something like that. What I will say, however, Joseph, is that after looking at DOMPurify for 2 hours with Kevin in that episode and kind of thoroughly understanding how the flow of HTML sanitizers go by reading this blog post and his second blog post, I find myself a lot more interested in HTML sanitizers. So like, I recently have an HTML injection, it's like, a benign HTML injection on a Google page. And I was like, well, let me just take a look at like how the sanitizer is working, right? And I go in there and I'm figuring out like, oh, these are the attributes I have access to. These are the tags I have access to. What namespaces are these all in? How are these attributes being parsed and processed? Is there any, replacement that's happening post sanitization that could allow, these attributes or namespaces to change? Where the uses of regex versus like, built-in browser DOM parsing functionalities. So there's a lot of stuff that can be learned from that. And the DOMPurify write-ups will really help you address HTML sanitizers from a higher level by looking at a case study of how Kevin does that specifically for DOMPurify.
Yeah, actually, I think that I have in my notes, I even think I sent it to you once. I'm going to pull out my notes right now, like just my own bug bounty notes. I think I had a list of the different ways that a comment in HTML parsers could be parsed. And I had like a list of payloads that I may have sent you. Yeah, I still have my conversation from to Ryan X, the healthy outlet right here. And I think I cleaned this up, but I'll send this to you, and then also we can drop it in the show notes or in the Critical Thinkers chat later.
Send it over. We'll find somewhere to put it.
Sweet. Just because I think that gives users something really nice, especially when you're talking about what you seek is what you get editor. You can paste all these in there as one block. And then just like, if any of them parse weirdly, it's almost like a single payload in the same way you would look for like an XSS polyglot.
Very nice. Yeah, there's like those XSS payload lists as well. You just paste them in and you're like, oh, that was weird. That's the one I'm going to investigate.
Exactly.
Yeah. All right. So number 4, worst fit. Hit me with it, Joseph.
Yeah. Well, I was going to say, I appreciate you giving me first pick because I went for this one. I do have to know, would you have picked it?
Oh yeah, dude. This is a great one. This is awesome.
Okay. I feel like it's the coolest one. I feel like this should have been number 1, but maybe I just love transformations. Yeah. So, if anyone is listening and they haven't read Orange's worst fit research, you need to go read it right now. Just search for worst fit, which is, such a cool name too, because the algorithm is called best fit, right?
That's right.
So anyways, I appreciate Justin giving me first pick because I picked this one immediately. Have you, since researching this, have you used these anywhere? Like, have you looked for oh, you have?
Yeah, I actually have gotten it to work too. Yeah, it was
you actually
amazing.
Popped a bug with it?
Yeah, I did.
Oh, sick.
It was super cool. And the
Did it use the yen? Did it use the yen sign?
Yen mapping. Yeah, dude. It's it's so cool when it works too, dude.
No, oh my god. Thread the needle.
Amazing. Yeah.
That's sick. Yeah, I'm excited about this. People obviously know you have a lot of connection to Japan. What people may not know is that I'm kind of connected to Korea because we have two of our kids, 2 of our 3 are adopted from South Korea. So that's pretty sweet. And actually, this is actually a crazy story. I'm gonna tell it and burn the extra 30 seconds because everyone will think it's really interesting.
Go for it.
My son, who is 6 years old, actually, you might not even know this story, Justin. It's kind of crazy. Was a part of this promotion when he was in Korea before he was adopted called Letters from Angels, where they bring K-pop celebrity stars and pair them with the babies and have them pose for a photo shoot. And Samuel's was not only picked as the baby, but then his photo was like on the front of Marie Claire magazine,
dude,
and was shown on the news and on TV in Korea. And the way we found out is really funny too. My wife was just like in like a Facebook group for like other adopted families from Korea. Yeah, his name is Kong Daniel. So if anyone knows, he like won the, what's it called? He won like the American Idol for Korea. Like this was, 5 years ago or whatever. And so there's a picture of naked Samuel on the front of Marie Claire magazine and on the Marie Claire Instagram.
Dude, that's hilarious.
And like on the internet and stuff. If I can, I don't know if I want to share a link. We'll see, but it's funny. I'm sure people can find it now. It's on the internet. Yeah. So maybe we'll just share a link.
That's gonna be great someday. When he's got a girlfriend, you're like, hey, check out this picture of it. And he's like, Dad, shut up.
It is the coolest, random fact or like 2 truths and a lie.
Yeah. Oh yeah. Oh my gosh. Yeah, that's hilarious. I was on front of a magazine as a baby. Wow.
Yes, exactly. Here, okay, I'm gonna share my screen, even though this is not about the episode at all. Okay, screen. Yeah, what's going on? Okay,
yeah, we're
cool. Here we go.
We're like, oh yeah, this is gonna be a tight episode, and then we go down these rabbit trails. Dude, what?
Is that amazing?
That's amazing, dude. Wow, so cute.
Yeah. So, anyways,
all right,
connection to Korea. My whole point is that I didn't know that there was like that the won symbol. So for obviously the yen symbol is the symbol for the main currency in Japan, but that the won symbol, which is the main symbol for currency in Korea, is also a potential worst fit. So I'm going to start using that now, and then what's out there that needle, I'll let you know. But so. If anyone has is wanting to jump straight to what's the most interesting, what's the biggest payoff here, obviously ANSI found a ridiculous, level of impact with all these vulnerabilities in a bunch of different ways. But one of the kind of the TLDR is that you should be using these 4 symbols. There is the full width double quote, which toggles quote mode, like basically navigate between places where quotes are often used to truncate strings or things like that. And that is code point UFF02. Then there's the yen sign, which will sometimes map to whenever it's when it goes through the best fit algorithm to \. And then the won sign, which is the Korean money symbol we were just talking about. It also maps to \. And so both the yen sign and won sign and then the full width \ can all be used to escape quotes or alter syntax. So Justin, what are you gonna say?
It's pretty crazy, dude. I have been using the double quote for a while because I don't know if you've got your keyboard set up for Korean or how it works for that, but I've got my keyboard. I can just press Windows key space and it converts my keyboard to Japanese, and then I can type in Japanese. And so it's very easy for me to just be all right, hop into full width characters, throw in the double quote, and push it through. And I've actually been doing that with less than signs and greater than signs as well. And they do pop sometimes. So that's definitely an easy thing to do. Just copy and paste them in.
So dude, why exactly why does a double width or why does a full width double quote even exist? Couldn't they just have used a normal double quote there?
Yeah. I don't know. When I switch into the Japanese mode on my keyboard, it all of the characters are double width. And so for example, if I hit A, it'll show me the Japanese character ah, right? But if I hit R, it'll show me a full width R, Roman character R. Yep. And then I can either press O or U to make do or do, the Japanese, letters. And so I don't know. I think it's got something to do with those just already being in Unicode mode for input, but it makes it really easy for me to just put in full width double quote and all that sort of stuff, because I'm already sort of in that Unicode environment.
Yeah. So if you're typing in like a string and like the text of the string is Japanese, is it like full width, double quote, then all the Japanese characters, and then full width, double quote again? Is that kind of how it looks like on a web page or something?
Yeah. It'll render as a full width double quote even on the page. So it's a different code point, which is cool. And is where this comes into becoming a problem when it doesn't fit. When the best fit matching is like a sensitive character, like a double quote or a backslash. And the one that I've had the most success with so far is the whole like forcing the page to get rendered as a like Japanese character set, and then the backslash becomes the yen sign, and then you can just sort of escape out of the JavaScript because the backslashes aren't backslashes. So that's pretty cool.
That's cool. Yeah, that is cool. It makes me just, I mean, again, amazed, and I'm sure that everyone thinks about this all the time, but just Unicode has caused so many security issues. If there was like a standard character set such that never was invented, it would have been so much better from a security perspective. Because even with all the AI stuff, with the piece I just put out, right? Like I included 2 tools that I put on my blog that you can go get to from the tools page, and they're both Unicode related. One is invisible Unicode tags, and the other one is like Unicode emoji variation selectors. And so both of those are ways to basically encode, a bunch of invisible information on the page. So anyways.
Yeah, pretty crazy stuff. We did cover this one also in more depth on episode 103. So if you want to go back and listen to that one, if you want more information on this.
Sweet.
All right, number 3, unveiling TE.0 HTTP request smuggling. Dude, I'm glad you chose this one because I don't know, man. Request smuggling, I found it only like 3 or 4 times.
Yeah.
And it's just one of those vulnerabilities that I'm like, I've seen, I understand how it works. I just don't hunt for that. And it's crazy because almost every live hacking event, someone comes with a crit from request smuggling.
Yeah, it does feel like it expanded the scope of the types of vulnerabilities to a much greater scale whenever this like set of vulnerabilities came out, because it can be present in so many different libraries and in so many different configurations. So I think in general, one of the coolest things that they did here was basically look at all of the existing request smuggling techniques, and they asked the question like, why not this other variation, right? And so the exact quote is right here. They said the idea. However, we eventually asked ourselves, why is there no TE.0? I'll actually share my screen so that the listener or that the viewers can see.
Yeah, because there's like TE.CT and CT.TE or whatever, but why not TE.0?
Right. So there's content length transfer encoding, transfer encoding.
Yeah, content type.
And then transfer encoding content length, and then transfer encoding transfer coding. But then the content length, which is treated the back end ignores content length header, which is then treated as 0, but the front end parses it with CL0. So it's kind of like, why not do TE0, which is just, a cool idea. And then did you notice that the thing they use to spin this up, and I'm sure that we talked about it, or you all talked about it back whenever.
HTTP Garden?
Yes. So it we've talked a lot recently about how it's so easy to spin up little things using AI, like to have it write Docker files or whatever. But this is just a full force multiplier in that regard.
Oh yeah, dude, this thing is amazing. I definitely have seen this a couple times. I haven't used it yet, but I think I mentioned it right on the episode right after I met the guy that wrote it at a Google live hacking event. And it was hilarious because he was just like, and if you look at the README, you'll see what what it's like here. But he was just like just sending data with printf directly into netcat, and that was how he was attacking web servers, right? He wasn't using a proxy or anything. He was just like printf to netcat, and then if you look at the README on this thing, they're doing something very similar. So it's very interesting.
Yeah, really cool stuff. I specifically think that research has all of a sudden become accessible to a ton of people that it wasn't accessible to before with AI. I was talking with Kevin Mizu to kind of like tie a bunch of threads together about some different ways to do prompt injection vulnerabilities, specifically some ways you could potentially get XSS if you can have a large language model reply with like a really janky markdown image link. And so he claims that he's like found this, like it definitely works in some scenarios. I was not able to replicate it, but the thing that I'm bringing up was it took me like 5 minutes in Cursor to just ask Sonnet to give me an example. Like I was like, make me an example HTML page with fake AI responses that are basically like this payload specifically. And I gave it the payload he had talked about where like you like escape some, you kind of make like a fake image markdown link where you escape some stuff and you give like an on-air alert as a part of the payload. And I said, but use like 3 or 4 of the most popular markdown image render libraries so that I can test all of them across to see which ones actually pop,
no
like
way.
which ones. And in like 5 minutes, or well, maybe less than 5 minutes, it just wrote the HTML page and it wrote the Python script. And then so I was able to just open the HTML page in my browser. And then I was able to see what the output from that fake LLM output would be had I gotten an LLM to respond with it. And that's it. And that hit me with this in the same way is it's like, if you have this idea, so like, I'm going to go ahead and apply it to what we were just talking about. We were talking about WorstFit, right? We were talking about those Japanese characters, the one character, the yen character, and then the 2 backslash or the double quote, and then the backslash. You could just ask AI to basically say, hey, I'm trying to do some novel research in the area of these parsers. Give me I want you to render these 4 characters with the top 5 Python parsers and the top 5 JavaScript parsers and the top 5 PHP parsers, and put it all on a single HTML page where I can see if they do anything weird, and you just like,
that's crazy, man.
Like you can do so many cool things like that today. And I think that people should do that. So
it's just all natural language too. You don't have to worry about any of these config files and stuff like that. But HTTP Guarding kind of does that for us already. Exactly.
Yeah. My whole point there was like HTTP Guard makes that even easier because it's going to like stand up a bunch of example HTTP servers that will, handle it differently.
Very cool stuff.
I did think that Google's bounty was kind of lame, since this was was vulnerable across like a couple thousand or something. Like the root cause of this one, the TE0, was vulnerable on a bunch of different bug bounty platform or programs, but the root cause was actually that there was a Google either IAP they were all either in GCP or Google IAP. And it resulted in these vulnerabilities. And Google is pretty good about paying out stuff with like big impact. And they paid $8,500 for this. But I would have expected something that was like cross a bunch of different organizations and a bunch of different tenants to have paid more from them.
Yeah, 100%. I wonder what happened there. I think it does get a little bit difficult to show impact on these sort of things sometimes when you're not sure how the app is actually used. But definitely, I don't know. In my past experience, Google's been more than fair with bounties, but I would have thought this one would definitely be well into the 5-figure range. Yeah,
and I think we had a similar comment from the critical thinkers. Like I think a critical thinker or two had a poor experience with Google. I think a lot of it depends on what you're reporting, where you're reporting, and then how you articulate yourself, right? I mean, yeah, we're pretty good about articulating ourselves, and we also aren't hunting on like really tiny sandbox things or what have you. But yeah.
Yeah, another one of the members in the Full-Time Hunter Guild got a 75K bounty though from Google, and got it was a 50K bounty and then a 25K bonus for a well-written report.
Yep.
Which is just nuts that they like. This is one of the most well-kept secrets I think of the Google VRP. Just look at the about section and go into the rules and scroll down to like exceptional report and just say like, hey, you need to include these 2 sections: root cause analysis and remediation steps. And if your report contains those 2 and it's a good report, then now it's an exceptional report, and now your bounty is 1.5x. And I'm like, whoa.
Huge. Who wouldn't do that? Yeah, everyone's gonna do that.
That's crazy. Well, and that also makes their bounty payouts like so much crazier, right? Because they're already good, but 1.5x it, and it's like, whoa, Do you know
if they still do that? I was going to mention this to you. Your vulnerability that you just found that you don't think will pay out that much, where it's like a crazy chain with like 5 different, blockers. It would probably make for an amazing write-up. They used to do like these huge bonuses for like really good write-ups. I feel like they discontinued it. Yeah, they would reward the top 5 write-ups of the year for Google bounties. My buddy found, I think, like a 10K bug or something. He's not a bug hunter, so it was really cool that he found this and submitted it. But his write-up got 2nd overall, and so he got like a $75,000 bonus. And so I remember him being like flabbergasted.
$75,000 bonus?
Yeah, I think first gets 125 or 150. They're very generous in that regard. They might not do it anymore, but best write-ups, Google bug bounty.
Dude, I'm gonna put more effort into my reports if that's the case. These are gonna be dang reports.
It's the write-up. Like they I think they want the publicity of it. It's not
they want you to do a write-up on the bug.
Yes, yeah. It has to be a public write-up on the bug. Yeah.
Hey, I can do that. I got a podcast. Like people will read it probably.
Yeah, seriously.
Blog.
Yeah, no joke. Seriously.
Blog.criticalthinkingpodcast.io.
Yeah.
Wow, very cool, man. I didn't know that. I gotta talk to Sam and Martin about that because that would
here
be
it is.
like that'd be
yeah.
sick.
So it was called 2021 GCP VRP Prize. I'll share my screen so you can see
GCP,
it.
so it's the cloud,
which is now in scope. They have like their own official bug bounty team. It's like in really great scope. I shared the wrong thing.
Yeah, they rock too. I submitted a little bug to them recently and got like this huge. They're listening, so shout out to y'all. Thank you for that really awesome response on the report. They were like, "Hey, tell the team I said hey." So they definitely listened to the pod. But
here, I'll move it over here.
Yeah.
Sorry, I've got to pull up. We can cut out this.
You're good. It says I got a little pop up here that says Joseph Thacker's browser needs screen sharing permission. So.
Oh, weird. Yeah. So,
dude, check this out. What?
Yes. So, this is 2021. I assume it happened after this, or maybe they just continued it. But yeah, look, they give first.
Oh my gosh.
So this is just for the write up. So this is like just to encourage security, researchers to focus on GCP.
No way. 133K for first prize. 73K
Look,
for
third
second.
prize. This is my buddy Mike.
No way. Third and second prize both get 73K.
Yeah.
Oh my god.
For just writing a good blog. That's what's crazy. But anyways.
Wow. Well, definitely going to suss that. I got to talk to the team about that. All right. Did you have anything else on TE.0 of request smuggling, or is that pretty much the TLDR?
Let's jump to the top two.
Okay. So I guess hold on. Let's go back to that. Takeaway from that is what? Easy to spin up testing environments. Yep. Use your brain when looking at
No. Not just use your brain. Listen, Justin, this is a good practical tip.
Okay.
When you're looking at let's say a set of payloads, a set of functionality, a set of connection types, right? You want to make sure that you're comprehensive in the different permutations you can get,
thorough.
Right? You're thorough, right? Yeah. So basically they noticed that this look at request smuggling originally wasn't thorough. It did not consider TE.0. Maybe it did, and who knows?
Yeah, I think he shouted it out in the original.
The Portswigger team's amazing, right? I mean, I'm sure they considered it. Maybe they just didn't find anything that was exploitable in the moment or something. They're busy changing the world. So, I mean, yeah, I think that's the key point, right? Is like, think about all the different happy paths or sad paths that can exist and make sure you test them all, and don't just assume that because one wasn't mentioned or one wasn't exploited yet that it's not exploitable.
True. I like that. Okay, cool. All right, let's go to the number 2 here, and then I'll let you take it away with number 1. Number 2, dude, this one was kind of the craziest. I don't know. This was crazy. Like when I was reading this, I was like, wow, really blown away. And I think it was an interesting comment that they had in the top 10 list. I think James said something along the lines of like, kind of crazy that this didn't get first place this year. It just shows how intense the competition was. But number 2 is SQL injection isn't dead. Smuggling queries at the protocol level, which was a DEF CON talk and write-up by P.S. Paul. And essentially the concept behind this one was applying James Kettle's sort of HTTP desync research to different protocols. And holy crap, dude, like really James changed the world with that HTTP desync research in the first place, because it inspires crazy stuff like this. So what this guy P.S. Paul did here was he investigated Postgres, Mongo, MySQL, and a bunch of other sort of database protocols, and sort of investigated what's going on there. And is there some way that we can smuggle data in at the binary protocol level, the protocol level where the programming language is communicating with the SQL server, in order to get sort of a smuggling sort of scenario. And the way he did this is by manipulating these binary protocol delimiters or terminators, right? So there's a couple main ways that he outlines in the article and in the talk on how these binary protocols are sort of structured. One, a lot of times they have null bytes, which are like the terminating characters. 2, sometimes they have length-based format. So you'll read like you'll read like a couple bytes and it'll be like, okay, the following 100 bytes or whatever are the payload. So consider that to be the payload. And then it reads 100 bytes, and then it's like another type delineator, another length, and then the payload, right? And you can kind of get data across that way.
Yeah.
And that's kind of what happened with these database binary protocols is they would have a length, which was an integer, and then they would have, a set of data. And what the researcher found, and what all of this boils down to essentially, is integer overflows in the libraries that are interacting with these SQL servers. So specifically an integer overflow in the length portion of these binary protocols. So if you send just an absolutely massive payload through to this SQL server, 4 gigabytes, about 4 gigabytes, what'll happen is the integer will overflow and become a really small integer for the length, right? So when it goes to read the message, it only reads like the first couple characters of the message. And then the data that then comes after that is no longer data, but it's actually a part of the binary protocol. And then if you can structure it properly, which he gave some cool tips on doing, then you can actually smuggle full SQL queries into this binary protocol and induce, arbitrary SQL statements, which is kind of like sort of a stacked query sort of SQL injection sort of scenario.
Is there like basically a no-op sled, just like a traditional buffer overflow? Like, if you're sending a 4 gigabyte thing and somewhere in there's going to be something you want it to execute, but it's probably quite small, like a single query would be tiny, right? So I wonder if there's like basically a no-op sled. Oh, there is. Yeah. Crafting a payload, no-op sled. Yeah.
Yeah, an op sled of that for sure. And they actually had a similar sort of concept in there that wasn't exactly an op sled, but it was sort of similar for the binary protocol itself.
Yep.
So yeah, that was really cool. Really awesome research here. And one little tidbit about 27 minutes into the video was a section that was entitled tips for sending big data to web apps. Okay. And I thought that was so valuable because he kind of gives a couple tips here that says, okay, when you're dealing with sending 4 gigabytes to a web app, like it takes a lot of time and a lot, you'd expect some component along the way to sort of fail.
Right.
And he gives some advice. Right. And so he gives some advice for getting around it. And one of the ones that I thought was great was just use compression. If the web server that's parsing it on the back end, let's say you've got Nginx in front of like a web server, right? Nginx is only going to look at the content length before it freaks out and says, I can't deal with this big payload, right? So if you can compress your data via gzip and just send that in like as a header and then send it through.
And if you have a massive NOP sled, it's going to compress to something tiny.
Absolutely. Yeah, 100%. And so very repetitive data. And so using that compression can allow you to get through like layers of middleware. And so that applies to like the reverse proxy sort of scenario, but also to the WebSockets scenario, because WebSockets also have some native compression that are associated with a lot of the servers that host WebSockets connections. So very cool. The other two here were use alternative body types. So maybe send like so you've got like XForm URL encoded, you've got JSON, and then there's like the MIME, I can't remember the name of it, multipart, that's what it is.
Yeah, multipart forms.
Yeah, sometimes that has bigger limitations or more generous limitations on it. And then also he said, try to find some way to do server-side creation of this massive string. Is there some way that you can run a programming language or something where it will output a massive string and store it in the database? If there is, then you might be able to use that to create this massive string on the server side. Then you don't have to worry about all of that sort of HTTP middleware. So I think as larger payloads become more impactful and have more of a place in web app testing, as this sort of demonstrated here, I think those tips are going to be really, really valuable.
So could the payload, I assumed based on the way when I read it, that it had to be like kind of like binary-ish data, like that you were like really constructing some like unique payloads. But if he's saying you could generate a big string server side via some web app, presumably there's some way to do this with just like ASCII data, right? Or like Unicode plus ASCII, right?
Yeah. Presumably, I didn't get he didn't really elaborate on that point, but it would have to be pretty granular, the actual exploitation piece. But maybe a smaller piece could be very granularly user controlled, and then the rest could just be inflation of the data, so to speak, that makes the overflow occur, and then you sort of are dealing with a smaller section of actually functional data, and that gets executed before hitting all of that junk, which just causes the server to ignore the rest of it. So very cool stuff there.
I wonder the last time SQL injection was top 3 in any, or top 2, for example, in any Portswigger top 10. It's probably been a while.
Yeah, SQL injection. I mean, this is, he says SQL injection. I don't know what this is, but it's not quite the normal SQL injection. Alrighty, man. Number 1, we got confusion attacks. This is orange. And it's yours, and it's not mine, and I'm glad because it looks complex. But what have we got here?
Yeah, so basically, like usual, Orange went super deep on something. In this case, instead of it being Unicode specifically, the big thing, the big key point here that unlocks a lot of this is the question mark. And so, I think that some hacker needs to make it their identity to basically be like the Joker from the very old Batman with the question marks all over it. Like that needs to be your shtick. We need some bug hunter to like make that their shtick. But yeah, I mean, he goes into extreme depth. But the point of it is that there's a lot of middleware. Again, we're really looking at secondary context here. It's a lot of rewrite rules. It's a lot of Nginx rules. And some of them are really interesting, and it makes me want to do exactly what we were just talking about, right? Use that HTTP garden to kind of see how these get handled differently. And it always makes me wish I could be omniscient and just look at the config files across like all the bug bounty programs to like grep for like this specific string. Like, are there rewrite rules with $1, right? Because it's rewriting that little path. And so, yeah, let me, I'll share my screen, but.
Dude, it's crazy whenever I see these write-ups like this, and the payload is so simple. He's like, yeah, and then I just put %3f in there, and I'm just like, what?
Yes, and then just the right place, and so it's always like really hard to know if he came to it top down or bottom up. It's like, is he checking everything, and he happens to find these one things, or is he at the bottom standing these up, doing code review, and finding them from the bottom up? Probably more the latter, but. But yeah, super interesting stuff, right? Basically, the issue is that there's like, weird replaces that are going on with these rewrite rules that allow you to kind of pop these different vulnerabilities. And
scroll down a little bit on this. The one that blows my mind is at the bottom here, right at the bottom of your screen, right there with the server upload. It says curl server/upload/1.gif, and inside the GIF, there's a PHP payload, and then he just adds to the end of that payload %3f. OOO.php, and then it renders as a PHP file. And I'm like, oh my God, this is nuts.
Yeah, so genius, right? And I'm sure some of us try little things like this here and there, but it seems like Orange knows exactly where to try it. He's hunting with actual like full vision, and the rest of us are hunting blind. So there's a bunch of cool stuff in here. I wrote down a few different things. One is on the path truncation part. So there's a bunch of different like primitives where, paths are getting truncated because of the %3f. I was going to ask you if you remember when you looked at this, or if you have like some sort of sniffer, like whenever you're testing, like what is your smell for if a truncation is actually occurring? Because I think there's so many times whenever you put a encoded character like %3f, %00, %OA, and it just like 400s or 404s in like a weird way. And my inclination, I have a hard time knowing if that's interesting or not. Sometimes I'll continue looking at it, sometimes I won't. And because like if it's interpreting %, like let's just say it's %2f. So I'm using a slash and I'm throwing in some %2es. If it's not ever being normalized on the back end, then of course it would 404, because who's going to name their file // right? And so anyways, I didn't know if you had some advice or some practical kind of like takeaways that helps you whenever you're in those situations.
Yeah, to be honest, dude, I mean, as a client-side hacker, I actually look at this sort of thing a lot, right? Like path normalization and like trying to smuggle past checks like this is super helpful. And, Orange uses it here more in a client-side perspective, but there's a lot of scenarios where if the server will parse a %2f, like a raw %2f, not like a decoded %2f as like a path delimiter, that's a crazy gadget. And so same thing with like the %3f, right? With question mark. If it is truncating the path at that specific point and that is becoming a query, then that is a major gadget in your toolkit. And actually, I'm going to add it to my to-do list right now for Kaido, because I really want to create a little Kaido plugin. It's super easy with workflows. Plugin to detect these sort of things, right? Because it should be super easy to just send / to one of them and then %2f. And if you get the same response back, then it's parsing %2f as a /, and same thing with like it's trying my to-do list app is parsing the % as a label. But yeah, it's a very easy gadget to identify, and it has so many different purposes across all of the application. And it's pretty common. I think I found it many times.
Yeah, exactly. Yeah, I mean, it doesn't surprise me at all whenever I have a server that interprets %2f as a /. Like you said, it's very
and
very common. So, I mean, obviously this is extremely deep. We're not going to go through all of it in particular, but one thing that I talked with you about before we went live that I thought was really interesting was this symlink. I think it's actually easy to find if you go to symbolic link. So I'm going to read a little bit of this, and then Justin can break it down, or I can break it down as well. But I was really curious about this section right here. So it says, to wrap up our jailbreak primitive, let's showcase how to perform an RCE using a double hop symbolic link. And so one, that just sounds really cool, but two,
what a badass.
Right, exactly. But two, I was like kind of confused how it worked. And so, here is his final payload. And then here are the two symlinks that he's showing you exist in order to get to this payload. So do you mind break down how this works?
Yeah. So the takeaway from this that I got was, depending on the configuration in Apache and HTTPD, it will follow symlinks. And sometimes you're locked into a specific directory because of where the document root is or where this thing is pointing back to. But there's this really handy thing called symlinks that will allow you to just jump into different directories.
Right.
And then, when you're in an environment where there are very far nested folders and symlinks sort of nested down like there was in this specific instance for Redmine, you can kind of chain those together. So hit a symlink, now you're in a different directory, find a symlink in that directory, hit that symlink, and now you're in a different directory, and then you can go down until you find, in this scenario, he was able to leak a secret key. So it's just a gadget for getting access to documents that are in a different directory that you're not normally scoped to. Because at the end of the day, all of these traditional web servers like Nginx and Apache, all they are is just exposing the file system, right? Over HTTP. And that's kind of what he's taken advantage of here, is using a sort of a file system technique, right? Symbolic links, and utilizing that to jump around within the file system, even though that's outside of his scope directory.
Yeah, so in this case, the secret key lives inside of Etsy Redmine default. Mm-hmm. And so we don't have access to that. So then he was able to basically go to, you want to get here. So you go to varlib redmine config, and that's why this config is here, because varlib redmine gets overwritten by this symlink. Mm-hmm. So you actually browse to this one place that you have access to, which is, HTML user share Redmine instances. And then that gets overwritten to varlib redmine.
Yeah, dude, this is impossible to represent in an audio format. So,
sorry for anyone listening. Yeah.
On YouTube that are trying to follow with this, there's like several symlinks and essentially it just dumps us in a directory where there's access to secret stuff. So
yeah, and I guess the big takeaway for anyone listening in audio is that I just never knew this was really possible at like a HTML web app level. Like, of course, whenever you like get code execution in a sandbox, you're trying to escape, you're looking for symlinks, you're doing this. Like, this is like very normal stuff. But I did not realize that you could basically construct a massive URL that included, to a web app that actually included like a double symlink hop like this. Very interesting stuff.
Very interesting. And it does require, I'll read this part right here. It says, in Debian Ubuntu distributions of HTTPD, the follow symlinks option is explicitly enabled by default. Love it. But even in non-Debian Ubuntu versions, Apache HTTP server also implicitly allows symbolic links by default. And then it provides a very common Apache snippet that I've seen time and time again with the options follow symlinks directive. So very cool stuff there. Definitely going to keep that in mind if I'm ever sort of in that environment where I'm scoped to a specific directory and try to have access to the file system to find these symbolic links.
Yep. And so then the next thing that I was going to mention about this was that Orange just makes me wish I had like 5 times more time to sink into like a single thing instead of like being like really spread out. And so, I know that obviously you do that on specific programs, that we both kind of do that, especially on like when it comes to a live hacking event. But it's really interesting the way that he sits down into a really deep well of knowledge, like a really deep well of a single application, and then all the implications that can kind of arise from that, and does a great job of like picking stuff that's going to have really, cross user, cross company impact. So pretty cool.
Very good stuff, man. Did you see this last thing right here where he's like writing an HTTP request raw? That's crazy.
Where is it?
The arbitrary handler to RCE, the thing you're actually on right now with the sharing your screen.
Yeah.
This was crazy. This like when we reviewed it before, I talked a little bit about this, but the first time I actually came across this, it's in the doc. I actually grabbed the link before we started. Was Franz actually doing a write-up on Nginx middleware misconfigurations, and essentially what he was describing in that scenario is a Nginx configuration where you can just start putting in new line characters in there, like %OD, %OA, and drop a new line, and then just rebuild the whole HTTP request on the back end before it reaches the the back end server. And I think those are so cool. I really, really do. I've never found one, and I would love to find one, being able to just rewrite the whole back end request. But Orange also does that here with some Apache configurations.
Yeah, I feel like there's a bunch. There's like not a bunch. There's been a couple different cases where you get this opportunity to do this. One I think is like kind of the request smuggling. You can sometimes like write an entire request that then's going to kind of get parsed. And then I think maybe it was Eric today as new sent me like I wonder if it was maybe actually this before then. I'm going to try to find the exact vulnerability that we were exploiting at the time and see if it is relevant to this. But I remember specifically that it had an encoded question mark in the get parameter, and then we built an entire request with other characters, and then it was actually getting executed, and it was it did not have a curl payload like this. It wasn't like, I don't think it was code execution in the same way that this location is in this request here. But it definitely did involve making, like, it ended up being an SSRF of some sort. And so I'll try to look that up because it was really interesting.
Wow. Yeah. There's lots of these across, I think, multiple environments, and it doesn't just affect Apache like he's talking about here. There's also this in Nginx as well, as Franz pointed out. So we'll link that blog post in the description, even though it's on Detectify's domain. Don't love Detectify anymore, but the research is still good. So check it out.
Sweet. Yeah. And then the one last thing, you may have something else, but the one thing I wanted to mention from this, that even, that this specifically and many more in here basically bring to my mind is that we work in the best freaking industry. Like, the fact that this is real life, that this is real security research, that we get to actually, I mean, it's just so cool, right? And we get to exploit these and, find cool vulnerabilities that we get to talk about and that we get to teach about. And I think that we work in the best industry. And so I just wanted to mention that.
Dude, it's so engaging. Like, literally yesterday, I was standing right there, right in front of my fireplace here, jumping up and down, screaming, like hugging my buddy because we popped a crazy bug. And it's just like, wow, this is my job. Like, some people go to work and they put in their 8 hours and they come home, and that's it. They don't like their job. But I get to sit here and scream and jump up and down and have this like amazing dopamine rush when you find a bug. So it's pretty sick, dude.
Yeah, and it's having this massive impact. Like, I was just talking today with Kieran, the guest from the previous episode, and because he's interested in potentially like chasing down a TEDx talk, and we were just like workshopping some ideas. And one idea that I brought up is just like, bug bounty has had an unfathomable amount of impact on the total security of the internet at large. Like, I think that the HackerOne report IDs, which obviously there's lots of NAs, lots of information, lots of dupes, but there's over 3 million. And I'm sure that Bugcrowd, Integrity, these other large platforms have very similar, report numbers. So I think we're approaching probably 10 millions in the IDs, but that is not even close to counting the amount of, like, when a SaaS vulnerability gets fixed, it gets fixed for all tenants, right? When a zero day gets found and patched in a library, and how many vulnerabilities are in libraries, SDKs,
so many,
plugins, so many, right? So we're probably talking on the order of tens of millions, if not hundreds of millions of vulnerabilities that have been found as a result of like the hard work of bug hunters like us. And I think that's really cool.
Dude. Hell yeah, dude.
It's
That's what I'm talking about. Give me some right now. Give me a fist bump through the podcast
sir.
right now. All right, guys. Well, hey, that's it. That's a wrap on the Portswigger Top 10. Congratulations on being in the best industry in the world. At least we think that's what it is.
Yeah, I definitely think so.
Yeah, and keep getting those bugs, y'all. All right, peace. That's the pod. And that's a wrap on this episode of Critical Thinking. Thanks so much for listening. And if you want more critical thinking content, head over to ctbb.show/Discord. Join the Discord. There's lots of great conversations and chats going on over there. And if you want to support the show, there's the Discord subscriber tiers, which give you access to masterclasses, AMAs, hackalongs, exclusive scripts, and an exclusive chat channel with us. We'll see you there.